welcome to the UGC lecture series. This is the EPG Pathshala lecture series on machine learning, and in this and all together 4 modules we will be talking about a very interesting and comparatively new technique in machine learning, which is a completely new paradigm called reinforcement learning. So, let us start with the basics of reinforcement learning. The people responsible for the development of this module are the following, and let us look at the learning objectives. So, what we are going to do is we are going to introduce reinforcement learning. We are looking at the basic elements of reinforcement learning. We are going to look at some applications from a top level. We are going to look at some applications of reinforcement learning, and then we will give finally a summary of this. So, what is reinforcement learning? That is the first question. It is a trial and error learning paradigm, okay, and it has rewards and punishments. Okay. Now, what do you mean by this rewards and punishment? I will like to tell you a very simple example to make you understand the concept of reinforcement learning, but let us just look at some of the terms associated with that. It is not just an algorithm, as I already told you, it is a new paradigm by itself. The way it is, the approach to learning is completely different. It learns about a system with minimal feedback, and then it behaves and controls the system based on this minimal feedback. And it is basically inspired by behavioral psychology, so let me tell you an example of reinforcement learning before we go further. Let us assume that your father is teaching you to drive, okay, and he is not telling you any instructions, okay. So, basically he is teaching you to drive, and you know some basics, but he wants you to drive well, so he is coming and sitting next to you and you start doing the driving, okay. Now, suddenly he slaps you, it means that you have done some mistake, you put a sudden brake or you are just on the edge of something like that. Now, suppose he pats, it means you are going at the cruising at the correct speed. So, what is this? That is the reward, the patting, and the slapping is the punishment. Now, what the learning algorithm will do is, based on this feedback that you get, okay, the idea of reinforcement learning is to get as many rewards as possible and to avoid as many punishments or that as possible. So, this is what is the basis conceptually of reinforcement learning. Now, let us go a little more in detail. Now, when we talk about reinforcement learning, we talk about environment. Okay. So, the environment has got a state and the agent does some action based on the environment, and based on that action you get a reward. Either you get a reward, the reward can be positive or negative, so we just put it as a reward. So, based on a state of the environment, the agent does an action, and based on the action the environment will give it a reward. So, agent performs the action under the policy, whatever the policy being followed, and the environment is everything else other than the agent. So, we are giving it a common term. Okay. So, learning from how do you talk about reinforcement learning? It is learning from interaction. Okay. It is a goal oriented learning. The goal is to get as many rewards as possible. If you get as many rewards as possible, it means that you have achieved, you have learnt whatever your goal, you have learned that. So, it is called goal oriented learning. It is learning about, from, and while interacting with an external environment. So, based on the environment you learn, state of the environment you learn, then you do an action on the environment and the environment gives you a feedback. Okay. So, you are learning from the environment and you are learning about the environment also, and you are interacting with the external environment. So, that is how it is defined. This external environment is what is defined, and learning what to do, for example, how to map situations to action so as to maximize a numerical reward signal. Okay. So, you are given a situation which is the environment. Based on the state of the environment you do some action, and based on the action the environment will give you some reward, and based on the reward you will decide whether this action was good or not, and next time you come across something whether to do the same action or not, so that you get better rewards. Now, let us look at supervised learning. You remember supervised learning, it is labeled information. So, you are given an input and an output and you learn a mapping function from that, okay, and you try to predict for an unknown. So, the training information here is will contain the desired target outputs. Okay. So, in the supervised learning system, you are given the training information and the inputs and the targeted outputs. You learn a model and then you give it an input, you are expected to get the correct output. Of course, what you give as input will be something you have not yet seen, unseen, you are supposed to get the output because you have learned the model. So, this is supervised learning. Now, the error you measure is you have predicted an output which is the target output, desired target output, and you have predicted which is the actual output, and the targeted one is what you would like to get. So, that minus target output minus actual output is the error. So, what you do is that error is used and you are going to change the model to minimize the error. Now, in reinforcement learning, the training information is only evaluations like its rewards or penalties. I said punishment in a loose sense or in a casual sense, it is penalties. So, what you have here is you have the inputs and the outputs are actions, okay. And the reinforcement learning system, the objective is to get as much reward as possible for the actions you do, okay. So, the training information gives those rewards and penalties. So, let us look at a general reinforcement learning algorithm. So, first you have to initialize the learner's internal state, we will come to that each one of that, and do forever, it is observe the current state yes of the environment, then choose an action A based on some evaluation function, we are going a little more detail. So, choose an action A using some evaluation function and then execute that action A, and then let R be the immediate reward and S dash be the new state that you get because you are doing that action A, and update the internal state based on the current state, the action you have taken, what is the reward you got and what is the new state. Based on this, the internal state is updated. Okay. So, I will just repeat these terms. You initialize the learner's internal state. Now, you observe the current state yes, and then you choose an action A to based on some evaluation function, then you execute that action A. When you execute that action A, you will reach a state S dash, okay, and associated with that action you will also be given R as an immediate reward. So, you update the internal state now to reflect the initial current state, the action, the state you reached because of the action and the reward. Okay. So, the key features of reinforcement learning is the learners never told what actions to take. The learners only told that after taking an action, this is the reward you get. So, he is not told whether the action is good or wrong. It is a trial and error search, possibility of delayed reward, sacrifice short term gains for longer term gains. This is another possibility that you can have. And there is a need to explore and exploit. We have come across this explore and exploit in many places. It is a search space. Trial and error means it is you are searching a space, and so there you have whether you want to search deeper or go more. Consider the whole problem of a goal oriented agent interacting with an uncertain environment. Please look at these terms here. We are talking about a goal oriented or directed agent talking with an uncertain environment. Now, let us look at the agent environment interface. Okay. Now, you have the environment and you have the agent. So, from the environment the state ST goes to the agent. The agent does an action based on ST, let us call it as AT, the action AT corresponding to the state ST, which acts on the environment. So, the environment now the environment has reached a state ST plus 1 because of the action AT, and the so that state is given and the reward for that is also given, the reward is RT plus 1. And that reward goes to the agent. So, for the state ST you could have given an award, and for the state ST plus 1 because of the action you could have given an award. So, there are two rewards that are associated here. So, S naught, take an action A naught, get the reward T1, go to S1, take the action A1, get the reward R2 because you have reached S2, on S2 take A2, reach S3 and get the reward R3. Getting this reward and reaching the state are almost simultaneous. So, S naught, A naught, R1, S1, S1, A1, R2, S2, S2, A2, R3, S3. So, this is the sequence of actions that will happen. Now, the task is to learn how to behave successfully to achieve a goal while interacting with an external environment. So, learn through the experience from trial and error. So, examples of this are game playing. The agent knows that it has won or lost, but does not know the appropriate action in each state, it just knows that. Control a traffic system can measure the delay of cars. So, that is some of the rewards. The rewards means not you will get a prize, it could be that there will be some other parameter that is not directly the state that you have. Okay. So, let us next look, that is the basics of reinforcement learning. Now, let us look at the elements of reinforcement learning. So, the first is policy of what to do, that you have to decide. Then reward, what do you consider as good, that you have to decide. Value, what is good because it predicts reward, that also you have to give a value for that. Model, what follows what. So, you have a policy, what to do, a reward, what is good, a value for that goodness, so that you can predict, and you have a model of the environment. So, these are the basic elements of reinforcement learning. And when we look at it this way, it is a transition model. Before we go to that, you have the environment, you have a state given to the agent does an action based on a policy, the action affects the environment, and then you have another state, and the environment also gives you a reward. Okay. So, now the transition model is how the action influences the states. Okay. Then you have a reward R, the immediate value for a state action transition. So, given the state and this action, this is the reward. Policy pi, which maps states to actions, given the state, what are the actions I should take. Okay. So, now let us take an example, and we are given the immediate values. Okay. So, you can associate with immediate reward values. So, you have a state and an action and a reward associated with that. So, for example, if you go from let us assume this is 1, 2, 3, 4, 5, 6, okay, or you are going from here to here. So, from here to here it becomes 90, this to this 81, this to this 19, this to this 100, and this to this. So, if you reach the goal state, you are in 100. Okay. So, this is the given a state and the upward, the action here is the upward movement, sideward movement, whatever. So, given a state and the action, you can specify upwards. So, the overall idea is the value of pi of s is equal to r of t, y of r t plus 1, y2 of y1 of r t plus 1, y2 of r t plus 2. So, each and every time whatever rewards you get, all that together should give you a value that will be a good value. So, the value function actually maps the states to the state values, each state what is the value. So, each percept E is enough to determine the state. So, that means you know what the state is accessible to the learner. The agent can decompose the reward component from a percept. Okay. The agent task is to find an optimal policy mapping states to actions that maximize the long run measure of the reinforcement. So, think of reinforcement as reward. So, this can be modeled using a MDP, which is a Markov decision process model. This can be modeled using that. Okay. So, let us look at what is the Markov decision process model. Markov decision process model consists of 4 parameters S, T, A and R. So, S is a set of states, A is a set of actions, T, S, A, S dash is equal to the probability of probability of transition from S to S dash given action A. So, given the probability that you are in S and you have done an action A, what is the probability of moving from S to S dash? That is called as probability, and that is also called as T, S, A, S dash. So, that is a probability value, and then you have R, S, A, the expected reward for taking action A in state S. So, what is the probability of taking action in action A in state S is given as an expected reward. So, you have the set of state, the set of actions, the probability of given the state and the action, what is the probability of transition to S dash, and the reward, the expected reward of for taking action A in state S. So, that this is called as the Markov decision process model, and R of S comma A is nothing but S dash probability of moving from S to transitioning from probability of transition from S to S dash given action S to S dash given action A, and the reward of reward associated with going to being in S and doing the action and moving to S dash. So, this can be replaced by the probability is nothing but the T. So, it can be replaced by that as T of S A S dash and R of S A S dash. Now, the reinforcement learning framework can be, already we know this. So, learn from close interaction, it is a stochastic environment, the noise delayed scalar evaluation can happen, and you try to maximize a measure of the long term performance, not for one action. Okay. So, that is what you try to do. So, let us look at it from the viewpoint of a Markov decision process. S of t is the state of agent at time t, A of t is the action taken at time t, okay. And then in S of t action A of t is taken and clock ticks and reward t plus 1 is received and state changes to S t plus 1. Next, state probability of S t plus 1 given S t and A t, and the reward probability is probability of reward t plus 1 given S t and A t. So, this is a Markov decision process that we have. So, you are in a state, you are taking an action. So, given the state and action, what is the probability of transitioning to S t plus 1, that is the state probability. Given a state and an action at time t, what is the probability of receiving a reward at t plus 1 is what is called as reward probability. So, you have an initial S state and in goal states, you have initial states and goal states. So, the episode is a trial of actions from initial state to goal. So, the term called as episode, it is nothing but a series of action from initial to goal. Now, this is not equivalent to some supervised learning, you can call it as very sparse supervision because no target output is provided, no error gradient information is available. So, action chooses just the next state and you explore to estimate gradient, trial and error, it is a trial and error learning. And so, you have the input, you have the agent, you have the output, and the error and the target are not given. So, it is not unsupervised learning because sparse supervision is available. Pattern detection is not the primary goal like in unsupervised learning. So, you have the input, you have the agent, and the activation is done and you have an evaluation. So, let us take an example of gambling. You have 3 different biased coins which are tossed. Okay. The coin to be tossed is selected randomly from the 3 options, and I always see which coin I am going to play next. I know which coin I am going to play next. I make bets on head or tail and I always wage $1. If I win, I get $, otherwise I lose my bet. Okay. So, that is a typical game of 3 different biased coins. You take the coin, it is tossed and is selected randomly from the 3 options. Once I get the 3 I can see which I am and I make bets. So, the RL model is X is a coin chosen for the next toss, the action is a choice of head or tail, and the reinforcements are -1 and +1. Okay. Now, I have a policy of going from X to A. Example, coin 1 head, coin 2 tail, coin 3 head. Let us assume that is the probability. So, the learning goal is to find a policy such that coin 1 is something, coin 2 is something and coin 3 is something, maximizing future expected profits, that is what I want. So, that means I need to get the maximum profit. So, I have t is equal to 0 to infinity gamma of t r t, where gamma is a discount factor, the present value of money, that is not very important. So, the model is model based approach to reinforcement learning. You learn the model and then use it to derive the optimal policy. This is called adaptive dynamic learning, which is the ADP approach. The model free approach reinforcement learning, derive the optimal policy without learning the model. So, you have two different approaches for that. We will be going into these details later. One is called LMS, we will talk about that, and then you have the temporal difference approach. So, which one is better? We will talk. So, let us now look at some of the applications of reinforcement learning. So, robo navigation is a typical example of reinforcement learning. Adaptive control, a helicopter pilot is an example of reinforcement learning. Combinatorial optimization like VLSI placement and routing, elevator dispatching, these are examples of reinforcement learning where it has been used. Game playing, backgammon, world's best player, that can be done. Computational neuroscience, modeling of reward processes can again be are applications of reinforcement learning. Now, let us take an example of a robo in a room, and that is a start. Okay. Now, the actions allowed are up, down, left and right. Now, slowly I am bringing a little bit of probability. So, 80% we will move up, 10% we will move left, 10% we will move right. So, we never move down, in other words. Okay. So, reward of +1 at 4,3 and -1 at 4,2, that is given. So, we are assuming it is a 4 by 3 matrix. So, so this is 4.0, 1, 2, 3, this is 0, 2, sorry, 1, 2, 3, 4.3 and 4.2. So, it starts here. So, 0, okay, 4, 3, 4, 2. So, it starts from here 0, 1, 2, 3. This is 1, 1, 2, 1, 3, 1 and 4, 1. This is 2, 4, 1, sorry, it is, yeah, this is 4, 2, this is 4, 3, this is 4, 1, this is 3, 1, 3, 2, 3, 3 and so on. So, reward of -0.04 for each step. What is the see when you say -0.04 for each step, it means that if you take extra steps you lose rewards. What is the strategy to achieve the maximum reward? What if the actions were deterministic? So, that is what we are going to do. So, is this a solution? Only if actions are deterministic, not in this case actions are stochastic, because remember 80%, 10%. So, what is the solution? Mapping from each state to an action. So, for example, now optimal policy is this. Now, reward for each step is -2. Here the reward for each step is -1. Here the reward is -0.04 and so on. Okay. So, what we are trying to do here is, what is the optimal policy? How do you want to start and reach? So, you could have gone from the start, you can go from the start and just go like this and reach this, or you can go 1, 2, 3, 4, but remember up you have 80%, but this direction you do not have too many percent, up you have. So, this probably this also is not a very good solution. So, you have remember that 80% the stochastic aspect is why it has become a little difficult to do. So, this is one. If you take the reward for each step is -2, if you take the reward for -1, -9, you can have different steps. Okay. Some notable reinforcement learning applications is TD-Gammon. This was done by Tisaro. It is the world's best backgammon program based on reinforcement learning. Elevator control by Kreitz and Bartow. This is again a high performance down peak elevator controller, and this is dynamic channel assignment by Singh and Bartek, the Bertsikas, and Nai and Heiken, both of them have done this. A high performance assignment of radio channels to mobile telephone calls. So, this is a very modern application and so on. So, there are a lot of applications that you have for reinforcement learning. So, in this particular module we outline the key features of reinforcement learning. So, first of all, this is a completely different approach and paradigm to learning, because we are not giving any explicit outputs. We have an environment, the environment gives us a state, and the agent, depending on some policy, it takes a action, and associated with each state and each action you have a reward, and the goal of the agent would be to maximize this reward. How you define this reward can be quite challenging, how you define the external environment can be challenging. This is not exactly supervised learning or not exactly unsupervised learning also. It is a completely different type of learning, because nowhere do we give the actual parameters, outputs or actual we do not give, we do not like in supervised learning, we do not try to find a pattern in the input like pattern, that is what unsupervised learning does, that also we do not try to do. So, we explained some of the elements and models of reinforcement learning. One was the Markov decision model that we process model that we explained, and the interesting thing of why this is important is each of the actions has a probability associated with it also. So, the probability of transition from one state to another state is when you take that action also has a probability. So, you cannot always choose the maximum. So, that is the challenge here. And we reviewed the Markov decision process model, and the rest of it we will continue with the basics of reinforcement learning in the next module, and then look at two very different types of reinforcement learning in the other two modules. Okay. Thank you.